degrees of freedom. There, let us see degrees of freedom. Let us consider the level process. To understand that, let us consider the level process. Level in the tank is H. The density of the process is rho, while leaving also rho. The area of cross section of the tank is A. What is the equation? The equation is rho Qi minus rho Q naught equal to A rho A dH by dt. That is one equation. Another equation is Q naught equal to B, a constant, square root of H. That is second equation. What are the variables involved? Rho, Qi, Q naught, A, H, B. Out of which these are the variables. Rho, a constant. A constant. B, also a constant. So we can strike out these constants. How many variables? 1, 2, 3, 4, 5, 6. Out of 6, 3 are constants. So if you remove that, you will get 3. How many equations? How many equations? Number of equations equal to 2. Therefore, degrees of freedom equal to 3 minus 2 equal to 1. The degrees of freedom of this level process is 1. Or I can say like this. Total number of variables 6, out of which I have 5 equations. Therefore, degrees of freedom is 1. How 5 equations? Rho, a constant. Rho equal to what? This is equal to say 5. 5 means it is a constant. That is also an equation. So, how many equations? 3, 4, 5 equations. Out of 6 variables, 5 equations are there. Therefore, degrees of freedom equal to 1. Degrees of freedom equal to 1. It means we can control only one variable. We can control only one variable. Suppose, without knowing this degrees of freedom, suppose I want to control 2 variables. For example, I want to control Q naught, outflow rate. I am putting here also one valve. To control outflow rate, I am putting valve here. To control Q naught, I want to control level also, level transmit. So to control level, I am putting one more controller here. I am putting one more controller here. Here, I am trying to control 2 variables simultaneously. I want to control level by adjusting inflow rate. I want to control outflow rate by adjusting this valve. It will not work out. That says the degrees of freedom. You can control only one variable. Either you can control outflow rate or you can control level. Only one variable alone can be controlled. That is called degrees of freedom. Suppose tomorrow test, your parent is asked to get good marks but you should go to bed by 9 o'clock. It's not possible. You cannot complete the syllabus within 9 o'clock. So, two variables they want to control. One is mark, another one is your sleep time. It's not possible. So, the degrees of freedom is there is only one, but you want to control two variables. Why this happens means the number of consistent, have you studied in the matrices? Suppose three unknowns are there, how many equations are required? Huh? Three equations are required. If there are four equations, the fourth equation may be redundant. Fourth, you can remove by using the row column elimination. You can remove one equation. If they are consistent, all the four equations are consistent, means automatically one equation will go off while doing row elimination, row column elimination. If they are not consistent, then you will get rank of A is not equal to rank of AD you will get. That is different story. Here, the number of equations should not exceed the number of variables. So here number of variables is 6. That's why number of equations should be 6 only. If you are implementing a controller means that is also an equation. What is the controller equation? The manipulated variable m of t equal to, what is the PID? Suppose you are implementing a PID controller. M of t equal to what? So let us assume that you are implementing a proportional controller. You are putting Kc multiplied by E of t. That is equal to Kc multiplied by E of t means what? Set point minus PV. That is Kc, set point is constant, minus PV is level H. That's all. That is also one equation. M of t equal to Kc multiplied. Now, if you implement this, the degrees of freedom becomes 0. If you implemented one controller, then the degrees of freedom becomes 0. So you cannot implement any further controllers. So number of variables can be controlled equal to degrees of freedom. Number of variables equal to number of variables to be controlled. Maximum number of variables to be controlled is equal to degrees of freedom. So that's why degrees of freedom is important. Degrees of freedom is important. Otherwise, you will be try to control more than the degrees of freedom. Here for a level process, degrees of freedom equal to 1. That's why we can control only one variable in that level process.